No time to waste. Let's get to our next very important and actually critical topic that we have on our stage, data centers. If you don't know what it is, you don't have to dig into technical things, but they run AI, they run our online connectivity. Basically, they do everything to keep everything running digitally, but they also eat energy for breakfast, lunch, dinner, and they snack in between. But in this part of Europe, besides sustainability, where cable cutting is a real-life thing, cyber attacks are being experienced daily, security is just as essential as the sustainability. So the question is, how do we feed this AI beast without blowing up the planet? We'll see how it goes. I would like to introduce, first of all, our moderator extraordinaire, Vice President and Principal Analyst of Moor Insights and Strategy, Will Townsend. Welcome back, Will.
Thank you, Artis.
With your applause, let's also welcome on the stage, he's the head of Data Center Business Direction at LVRTC, Jānis Delviņš. He's the Chief Technology Officer of Central Europe at Nokia, Nils Kleman. Welcome back. He's the Chief Technical Officer at TET, Dmitris Nikitins. Mission Director for Sustainability at the Alan Turing Institute, Adam Sobey. Welcome. And last but not least, he's the Chief Technical Officer at DataCrunch, Artūrs Polis. Well, let's have some fun.
All right, let's have some fun here. So data centers have to evolve. When you look at the demands that modern AI are placing on them, I'm beginning to see this with connectivity. We've had scale out, scale up, so your front end, your back end networking, but scale across is also occurring to interconnect these data centers to support these huge clusters. And at the end of the day, there's a lot of concern globally around the power consumption, around the sustainability, not only from an energy perspective, but how do you cool these things? I mean, how are you better equipped to manage water consumption and that sort of thing? So I want to start the panel with just getting a perspective from everyone on what can data centers do to meet these growing demands and stay within these sustainability footprints with energy consumption and water usage and that sort of thing, because it's a dire issue, right? So maybe we can start with you, Jānis, and just get your perspective on this.
Yeah, first of all, I have really honored to take this panel, because in this kind of Techritary forum, we all discussing about R&D and development, but every development project at some point you hit the ground, and infrastructure is already hit the ground, and now we are start from here, basically 3 years ago. About the sustainability and about how data center can meet, I don't think a really big romance in sustainability as a data center operator, what LVRTC do, because there is, from the ESG standpoint, all like the guesses is how we can decrease the consumption of the electricity. But the fact is that the IT power load is always increase. In example, in our customer experience, customers who 5 years ago IT power consumption was 2-3 kilowatts per rack, and at the same time this year, the same customer IT power consumption goes up to 20 kilowatts per rack. It's a small example. That's why what we can do, basically the main components, how we can manage, how we can provide redundancy, multi-modular electricity point of view, also optical connectivity, And about the cooling, we need to focus on the maximal available power usage efficiency with maximize air cooling stuff. And also everything knows about the next stage, and already what's happening is liquid cooling.
Right, and there's a lot of focus on the semiconductor piece as well, right? When you look at these parts that are these GPU parts that are manufactured by NVIDIA and AMD, and I recently learned about an etching capability where you can actually etch into the wafer, into the silicon, to help relieve the cooling and that sort of thing. But Nils, I'd love to get your perspective. Nokia obviously does a lot of practical research, and you and I were talking about this before the panel today. Can research sort of kind of close the gap here? What's your perspective?
Let me start, I don't know if you can hear me. Let me start first, perhaps, the importance of the cloud and data centers. I think we need to reflect. We are now able, as an industry globally, to reach 100 million subscribers in 2 months with OpenAI. So this is therefore the question, why is that? Because we have the cloud, the data centers and the software and the flexibility and scalability on that. And of course also we have the networking part.
Right.
So, and what we see also when we talk about the networking part, where of course Nokia is very active, also here we see very clearly during the last couple of years that either, 3 ways what to do with the network functions. Either you put them on a silicon system on chip, like we have our own chips for IP optics and mobile, etc. Or you put this on an appliance, because there is and will remain an IP router or optical router, etc., a physical thing. Or you put everything into the cloud, even from a network function perspective.
Sure.
So this is what we see from an application side, from a networking side. And then comes, of course, around the corner AI. But also here, a lot of activities are ongoing there. We see, competitive factors. At the beginning, it was, of course, a GPU. The big company starting with N, and it's not Nokia.
Right.
And of course, they also, on the chip development, they get better and better on this so-called teraflop per watt. So this, of course, is a continuous innovation, what the chip developers are providing more and more. But we also saw in the last couple of months, and perhaps last 2 years now, 2 other, of course, competitive factors, which is, of course, the energy, which is needed. It's becoming a competitive factor here. That's why they dislocate, they go into more inference, for instance, for AI.
Right.
So really distributing it, going where the energy is. Or like, for instance, we are, as Nokia, we are collaborating very closely together strategically with Nscale, European hyperscalers. So we've put a big gigafactory into Norway. Why? Because it's cold there and they have all renewable energies, etc. there. So it really becomes a big factor. And then, of course, I think that's the most exciting question on the context of AI and big language models. The efficiency of language models will play a big role.
Sure.
Because as we can all imagine, the more efficient a language model is, let us think about DeepSeek, what suddenly happened with the stock price of this big company within.
Right.
So what if we develop language models which don't need so much processing power?
Right. Yeah.
So these 3 angles I see now playing, plus of course, as you mentioned, the cooling and all these other things. But these are more or less have to be all balanced out.
Yeah, and I think the trend with modern AI going hybrid into network edges on new classes of AI-enabled devices and PCs as well potentially alleviates a lot of the pressure on the traditional data center. And to your point, we're only going to see even the larger language models become more efficient, right? And that should theoretically reduce the power consumption. But Dimitris, what's your perspective on this balance of sustainability, but still meeting the needs of the modern AI era?
Yeah, so that's pretty complex question. TET is the largest data center service provider in Latvia, with a lot of countries in our export portfolio as well. But putting emphasis in a question what data centers can do to be more sustainable, it's not really fair. So basically, data center providers are doing quite a lot. For example, we are constructing a new data center with the heat exchange with the local municipality to give the produced heat away. We are using the free cool. We are increasing our power efficiency. But data center providers can do as much as they can do. So basically, we should look at what is driving the power consumption in data center area, and basically that's AI. If we look at projections, then by 2030, power consumption by data centers due to AI consumption will double or triple, so the different sources. And in this case, we have to look at the whole AI supply chain. So basically, there are data center service providers, there are AI service providers, and of course, there are vendors who are producing the chips and so on and so forth. So starting from the chipsets, there is a lot of different research how we can be more efficient. For example, using different chips for inference, which are more energy efficient, chips which can work under higher voltage and increase power consumptions. There are different crazy researches as well. So this neuromorphic semiconductors and so on, which are basically in a starting stage right now in development. But some of them, according to data, seem pretty promising for the future. So from our perspective, there should be a push towards the vendors, because power consumption creates majority of footprint during the operation. And we are doing that. We are talking with the different vendors, and of course the highest driving forces in the data center area is the hyperscalers, Google, Microsoft, Amazon, which are driving the development and the research as well. The third party is the AI model owners, and they should be aware of the power consumption as well.
Sure.
So basically, if we are looking on the model training, so if we strive for perfection, we are training our model, so the biggest power consumption goes towards the last 5%. So around 40% of power consumptions are being spent to polish the model for the last 5 or 10%. We have to evaluate, does it worth it? So maybe this small margin of error does not worth the energy consumed during this retraining process. And the same is regarding the AI model optimization, which was mentioned previously. So now for the narrow application, we are retraining the whole model. The huge neural network we are retraining for this narrow application. So some algorithms should be in place to optimize the neural network to be able to narrow down the model or algorithm for narrow application and being smaller training data for that sense. So it is the complex question which all the parts of the supply chain should chip in. Otherwise, we will have quite a big boom, and we will increase our carbon footprint pretty seriously. And the second point is we are talking all the time about the operational footprint, which is being produced during the operations of the data center. But building data centers produces a lot of carbon footprint also. So a lot of companies, particularly hyperscalers, are looking into new kind of construction materials to reduce that carbon footprint as well. So there is no easy answer for that, but the whole members of the supply chain should chip in to improve the situation.
Yeah, no, you make some very good points. And on the latter point, in the United States, local communities actually get very upset when they learn that a new data center is being constructed, right? And so the hyperscalers have to go address that. And in fact, AWS decommitted to a construction in the Herndon, Virginia area because of this. But on your first point as well, what I'm seeing is the evolution of x86 CPUs from the likes of AMD and Intel that are becoming more and more capable of that inferencing capability, right? And I think that potentially sort of offloads some of what traditionally a GPU does. And then on your other point around connecting the model builders with the silicon providers, I think a great example of a start to that is the recent news with OpenAI and AMD entering this joint partnership where OpenAI is agreeing to take I think initially it's 50,000 sort of GPUs, but there's going to be some cross collaboration I would expect there to fine tune those models, make them more efficient on that AMD EPYC platform. But Nils, did you want to comment?
Just a short comment on this one. When we say building new data centers, not necessarily now the big gigafactories, but the ones for inference, perhaps even for enterprises themselves. Here we are asking or talking a lot also with our customers being the communication service providers, talking especially about buildings, properties, etc. What do communication providers have? They have tons of thousands of base station sites. They have central offices for the fixed side. So what do they have there? They have property, they have electricity, certain, let's say limited perhaps, but they have electricity and they have connectivity to that, preferably even a fiber connection already. So, and we see already many operators, CSPs, customers from us, gone into this market now, because I mean their market anyway is flattish, the classic market. So for them it's a huge opportunity to leverage on these assets they have. Like for instance, Verizon just launched, I think early this year, AI Connect, on the path of network cloud continuity, collaborating I think with AWS. Orange is collaborating with Google, so they are launching in a collaborative mode new data centers and leveraging to the carbon neutrality new data centers, certainly smaller ones, but it's not only the gigafactories, right? We need many more other data centers.
Yeah, it's a natural adjacency for the operators, and I spent a lot of time with AT&T, and they're almost in the real estate business. When you look at those nondescript buildings and that don't have an AT&T logo on them. So excellent point. So Adam, this is obviously a very tricky balance. What's your perspective on this?
Yeah, so it's always a little bit tricky going this end. I kind of wish I'd sat that end because Franz made some really nice points. So I guess I'll just illustrate some of those maybe with some examples. I think the point around there's not a one-size-fits-all for these data centers, and that globally there are different solutions. I was in Singapore, saw their national compute. They're on the equator, but they don't use any aircon at all because it's totally water cooled there, which is amazing. You're in like equatorial heat inside the computer, and I think that's quite unusual for most data centers. But they looked at water security in the 90s, and they have an abundance of water there that perhaps other areas don't have. Whereas if you're in Brazil, their supercomputers miles up a mountain, so it's naturally much colder than the rest of the city. So you can look for examples where you can utilize...
leverage the environment and leverage the natural resources, right?
Yeah, exactly. So I think that's important. I think there's a security sustainability issue. If you look at Chinese LLMs, then they are substantially higher in energy usage right now due to the tariffs on NVIDIA being unable to sell there. And we're probably seeing in 2 or 3 years' time, maybe longer, I'm not an expert in that area, but where you'll probably see Chinese microprocessors being more efficient than Western processors. They're catching up.
They're certainly trying to invest in that. Like companies like Huawei have silicon design, but they haven't had the fabrication capability.
Well,
right?
yeah, and so will they, once they get to that stage, be selling to Western markets? So you'll see a security blocker to sustainability, where perhaps we might want to be buying those for efficiency gains, but we might not be able to. And I think the third element around the small language models is really exciting. We built a model for the NHS, which was a small language model. We used 400 kilowatt hours per month for that model, whereas utilizing a large language model would have been 34,000 kilowatt hours per month, just for that one application.
Right.
And so I think really educating people around that energy use and then providing solutions, which are then more secure as well than utilizing the large language models, could give some really nice examples, but requires the skill sets to be able to work out when that's the right solution and have the people to build those models.
Yeah, and I think it's matching the proper infrastructure to the model. And you know, when I speak with journalists, you know, I remind them that we're still in very early days, right? And so this is going to be refined over time from my perspective. But those are some great points, Adam. And then certainly not last but least, Artis, like what is your perspective on this this challenging balance that we're discussing?
Yeah, thanks, Will. So I guess there's many thoughts that arise hearing all the panelists before me. I think that everybody was raising really excellent points about how the density per rack is increasing dramatically from a traditional kind of data center / hyperscaler model where you have 2 kilowatts and 10 kilowatts, and now we just deployed a DataCrunch first case of rack scale compute in Northern Europe. I think we just turned on the power this week, and that's NVL72 GB300 rack scale device from NVIDIA. So that's a GPU is now the whole rack, right? So you used to have one GPU would take 500 watts, 400 watts. Now this one GPU takes 130 plus kilowatts of power at peak operation. So you need to be extremely conscious of even cost of energy per token, and that's in some ways like how do you make things sustainable? You need to price the negative externalities of not doing things sustainably in, because you cannot rely on just goodwill of the actors in a market. You have to have systems which encourage companies to behave responsibly, and I think a lot of recipes were offered here as already now. For example, what we are doing at DataCrunch, so we are Nordic, Northern European AI cloud provider, so we are running quite a lot of top-of-the-line GPUs. However, from the very get-go, we made decision that we will only work with sustainable or green energy, so we pay actually voluntarily slightly more for our power to make sure it's certified from green sources, and we obviously encourage others to do that. But I don't believe. I mean, there's a lot of temptation to like cut down on your OPEX just a little bit.
Right. I mean, to improve your profitability, right?
Yeah. So your margins are a bit nicer if you don't do that. So it's a thing that. But at the same time, we see in some locales, some locations, there's kind of like a pushback against data centers where there's overbuild. Like I guess I suppose Texas would be like a prime example on everybody's minds, because the grid is not great already as it is.
I live in Texas, by the way. And we operate independently from the rest of the United States. Yeah. We get a lot of grief for that.
Yeah, and then you guys are running like gas turbines because you cannot rely on the grid itself, and then there's a backlash. So I think there needs to be the key thing is to figure out a way how to integrate data centers into the social fabric, because we will need these intelligent factories one way or another. They're here to stay. These are like, I mean, this is a railway moment, right? We are building those railways
That's a very good analogy. Yeah, it really is. Yeah.
For the intelligence right now, right? And how do we make sure that we don't pollute our cities and just have that as a responsible citizen, just one of the things that humanity will need from now on. So I think all the recipes here mentioned was efficiency per models. Like I was just watching a talk by Andrej Karpathy yesterday. He was running the Tesla's self-driving car division for 5 years, and he believes that our models are actually too large right now in terms of parameter count, right? So we are like hovering around the trillion, and he believes that you could have a distilled model at around 1 billion parameters, and that dramatically decreases the power requirements for rudimentary tasks. But then again, things like Jevons paradox kicks in when token price goes down, then suddenly all these uses for LLMs and for AI models unlock, then that induces more demand for these data centers. So picking locations where you can run, efficient cooling, where your power PUE kind of ratings are low, so that all of the power goes into IT and not the cooling. So, but yeah, I mean, there's a lot of these aspects there.
Yeah, it's and how motivated is NVIDIA or AMD or eventually Intel when Intel catches up to being more efficient, because it's like faster means more profitability for these silicon providers. But I'd love to shift the focus and talk about security, because it's equally important that we ensure the security of what we're doing here relative to balancing the need for sustainability and performance. And so, Artis, I want to start with you, and then we'll move down the line here. But from your perspective, from my perspective, AI is being weaponized against AI, right? And there are a lot of companies that are focused on runtime. There's a lot of focus on endpoint. But where's the focus in the data center from your perspective? What should we be considering to ensure the safe, secure deployment and use and operation of these data centers, whether it's AI workloads or just your garden variety workloads?
Right. Okay, so in my mind, I would sketch it so that there's multiple tiers of security, ranging from physical security, then you have security of, you want to sort of modularize your deployments, and then in terms of still hardware, and then going deeper and deeper, you go into software and actual models, and when you run the models.
And agentic frameworks and that sort of thing, right?
And then you have like kind of, encryption at runtime, so that there's zero way of eavesdropper to look at the workload or the tokens being processed. But then again, the security will be dictated by the actual requirements, by the functional requirements of what are you building. Are you building for a dual use? Are you building for consumers? So then you're stringent. But the key principle there, I guess, when you build these deployments, there should be. I'm not a data center builder, so I'll let guys from TET and LVRTC go into the physical requirements.
Right.
But when you look at just how you wire it up and how we are a cloud provider, so we build cloud, we build storage, we build training, inference systems, and what's important there is you essentially implement kind of zero trust policies that you have that you, even if someone gets into your system, you need to make sure that they cannot traverse it freely. Mm-hmm. So you have authentication internally at all layers, and this is just basic IT security, how you build a secure IT network. But then in terms of actual model runtime, again, this confidential computing where you encrypt data at rest, in transit, you need to encrypt data also while it's being processed. So whether you opt in to do that, sacrifice some of the performance for security. These are trade-offs. So you need to figure out what kind of trade-offs you're willing to make, and then see at every layer of your security setup which trade-offs are you making and what are the costs of them.
Yeah, and the silicon providers are very focused on root of trust as well. And I've had the opportunity to work with Intel, and they commissioned me to write a couple of papers, and one of them was a focus on Xeon and what they're doing around extensions to kind of safeguard against this. Adam, what's your perspective on just overall security, whether it's physical, agentic, or in the runtime?
Yeah, so I guess most of it comes back to education for me. And I think it's generally the smaller companies who are struggling with this because they don't have the skill set or the knowledge. It can be difficult to determine whether you're safer putting something on the cloud or holding it within your own company.
And there are a lot of concerns around, do I need to repatriate from the cloud and put all this on-prem? So there are these divergent sort of opinions, right?
Yeah, but keeping it on your own computer isn't automatically
right.
a safe solution either. So I think making sure that this is a priority within company structures, and I think that comes from leadership. I think you often see that CEOs, for example, see this as someone else's problem.
Right.
Like this is like IT's problem. They'll solve it. And I think that if that doesn't come from the top, and actually a lot of the security breaches tend to come from CEOs, for example, using ChatGPT and putting data on there rather than people on the shop floor, so to say. So I think it's around ensuring that element. I think there are good solutions for many applications. I don't do a lot with military, so I realize that's probably a slightly different sort of branch, but I think for most people there's good solutions, but it's understanding the right one for you and your company.
Yeah. No, I think education is super important, and it's being purposeful about it as well. And top-down can be effective, but when you look at just where modern AI is today, and it's stuck in proof of concept, right? All these different reports. MIT published a report. 95, 96% of modern AI POCs are still in POC, right? So that's an excellent point around education. Dimitris, what's your perspective on the security element here?
Well, being located in Latvia and having in neighbors the one who we have, so basically that's the subject we can talk about for hours.
Right.
The cybersecurity is the thing we are not willing to compromise on. So basically we have to keep everything to the highest standards, because there are a lot of different actions from abroad, both politically motivated and commercially motivated as well. So regarding the cyber security, of course, as mentioned, zero trust architecture, that's the basis of everything. And we have to ensure that. Of course, we have to ensure that we have automated scans throughout the networks to find those weak spots first, and not to allow someone to exploit them. So automated red teaming is very important nowadays.
And you're seeing a lot of that functionality in solutions from Cisco with its AI defense and that sort of thing, right?
A lot of vendors are working towards it, and of course service providers like us are working towards it and adjusting the mechanisms as well. Of course, we have to look what can help us to secure our data center infrastructure in the future as well. So we are testing and experimenting with quantum technologies, so securing the connections between the customers and between the data centers on the physical layer is very important as well. So not to let someone act as a man in the middle. We have to invest a lot of effort and a lot of funds into the cybersecurity measures. Both because of our geographical location and of the developments which are happening in the world right now.
Right. I want to, as we close, I want to go back to the quantum computing and the need for post-quantum, encryption and cryptography and that sort of thing, because I think it's going to be here sooner than we think, right? But Nils, I've worked with Nokia. There's a very discrete focus on security within your autonomous networks platform, which has some connectivity back to the data center. But what's your perspective on the security element here?
Yeah, I think here we have several aspects, and first big title should be no compromise. But the question is, how do we define security? Is it encrypting and the privacy of data, of course. You mentioned already quantum secure, like for instance we have already on the optical layer, we can encrypt quantum safe today when it comes to data center interconnect, for instance. But also on the other side, for instance, yesterday was Fastweb in Italy was off the net because of a DNS failure. Certainly, I assume a DDoS attack here.
Sure.
So how do we secure, for instance, all these networks against the DDoS attacks here? And also here we need to think, just as an example, to change our mind, because how do we usually mitigate DDoS attacks? So we identify the bad IP packets and then we route them through the whole network to a scrubbing center. You can imagine with the traffic take-up, this is not very
the overhead
scalable.
associated with
No,
that.
but also so what we are now doing, this is a new approach, and we can do this already, for instance, on top of a data center gateway. So we are scrubbing already on top of the router.
Right.
So with this we get much more scalability. But that's one part. But beside data security, I think we also have to talk about resiliency when we talk about security. So, and I will not repeat everything what was said already, I think several times in many of the panels here, so digital sovereignty, where are the data, where are the data centers, where are they operated, who is operating them, who has access, authentication, all these things here. And the third thing I would say is also from a perspective of security to protect our people also here. So by just making a mistake, so that's why you mentioned autonomous networks. This is very high on the agenda of all our customers, because just to avoid that a semicolon is missing or whatever, and suddenly the whole thing goes down. So therefore we say we need to go into intent-based automation. That's what we're also, of course, supported with AI, etc., but not necessarily everywhere. But intent-based automation, for instance, what we are offering as an operating system for the whole data center networking inside the data center, our EDA, so where we really do this intent-based. You just say this is what should be achieved, and where the semicolons and commas are being set, the system is doing them.
Yeah, and
so various aspects.
And you know, the whole notion of intent-based networking is not anything that is new, but I don't think we had the automation stack, 8 or 10 years ago to deliver on the true promise, because I remember being very critical of Cisco and when Chuck Robbins became CEO, and it's like, hey, this is all great, but proof is in the execution, right? And I think you made a real interesting point about what Nokia is doing with that software stack sort of on the router level. And what I'm seeing from companies like Cisco and Hewlett-Packard Enterprise are a new class of switching that is smart. They have integrated DPUs from the likes of NVIDIA or Marvell or whoever. And what you can do is you can embed not only networking services, but security services directly on that switch. And that's another, as one of the esteemed panelists mentioned earlier, that's another layered sort of approach, because at the end of the day, security is about kind of a layered architecture, but still, managing, tool sprawl and that sort of thing. But Janice, let's have you kind of wrap up this topic with your perspective on security in the data center.
Yeah, Artul's start this topic by layering. Yeah, I touched the physical part of this. I have and few in this panel who have don't have in role name, yes, technical or tech. I'm just a business manager, yes, and that's why. So I said we need to give a service that the customer wants. Yes. Basically, at the end of the day, my like a point of view is the Excel, yes, the business case.
Sure.
And in our company, security is top priority. It is our DNA, because 100 years we are operating critical infrastructure, starting from the radio and television broadcasting to this day, operating data centers, lease optical fibers, quantum cryptography, developing, etc. And in that case, our security is top of that, because about the optical connectivity, physical optical connectivity. The standards is we are the least way how what the customer asks is 2 independent ways, yes. In our scenario, we are discussing and thinking and developing the infrastructure units who have 4 independent ways by optical, because in zoom out, the Baltics is the part of Baltic Sea circle, yes, connectivity way. And we can imagine the circle without the Baltic region, and that's why we need to be as much as redundant we can.
Sure.
And also we need to provide high availability service for customer as hyperscaler. Everybody, I think, in next 3 years, every internet service provider will be the hyperscaler about the IT power loads.
Or a neo cloud, or all these emerging things. And I think one of the big challenges that I see, because I spend a lot of time with customers, it's oftentimes security brings with it friction, and so infrastructure providers, software solution providers need to really focus on a secure by design approach. And I applaud CISA for extending that, and creating like a pledge. And a lot of companies like Microsoft have taken that pledge, and at Microsoft they're actually putting accountability behind that. They're installing CISOs in every business unit, not just Microsoft's security portfolio, but think about their entire portfolio from Office 365 to Teams, and they should continue to improve on Teams because I'm not a huge fan of that collaboration platform. But I think taking a security first design approach is really, really important. So with that, in the last few minutes that we have, I wanted to just have each of you provide some perspective on, and we touched on quantum, so I'm sure one of you are going to pick quantum, but what emerging technologies can really sort of address everything that we've discussed today, balance the need for sustainability and power, and deliver security at the same time. And so Janis, let's start with you, and we'll move on.
In really short.
60 seconds.
Yeah, I think modular edge computing, combining with sustainable air cooling near to like hot air users, yes, hot water users, etc. Right. Compare with efficiency, compare with redundancy, and all connectivity with the need for infrastructure.
Okay. Nils, what are your thoughts?
I don't know if I got the question correct, but in my view, also let's not think that we only talk about big language models and big gigafactories. There are also very small ones which are running on our smartphone. Mm-hmm. Since
like Qualcomm chipsets
since
can
iPhone
support
15, AI. I think this is even supported on top of the smartphone. So on IoT devices, etc. So this will drive, of course, much more variations of data centers. This will drive much more different demands and requirements. Mm-hmm. We see much more players. I mentioned the example of communication service providers in the future. What are they playing?
Sure.
What are the digital sovereignty is happening, and also pulling, we call it repatriation of the clouds, for instance. So a lot is happening, and of course we are going to see then also great new technologies, solutions, players, and the ecosystem in very particular segments developing. Mm-hmm. So and then of course how quantum will play into this one. So we will certainly have a quantum computer in the corner of a big gigafactory eventually.
Right.
Or perhaps somewhere else, we're going to see quantum computers in whatever in the networks, doing some radio optimization or whatever. So it's amazing times, lots of opportunities, lots of challenges, problems to solve, but I think certainly the opportunities and possibilities are on the higher side.
Yeah, and I think, from a quantum perspective, you're starting to see purpose-built silicon emerge that, manages quantum entanglement, and I don't profess to understand what all that means with electrons and photons and that sort of thing, but But there's exciting sort of new developments that are occurring. So, Dimitris, from your perspective, do you see anything from a technology perspective or a new enabler that can address these challenges that we've been talking about?
Well, the amount of data will grow, and the amount of compute which we will use, of course, will grow as well. And from technology perspective, the chipset manufacturers will play a huge role in how we look, how we shape the industry, what they can come up with, and how they can improve the efficiency, and of course the security as well. We see that different network equipment vendors are producing the new chipsets with the built-in security, which actually we love because it helps us to secure our network better at every stage of the network, and the fight against the malicious actors are a bit changing, and that's giving us more tools. So the chipsets is one. The second one is, of course, we have to, for ourselves, to understand how we are using the data, whether it's making any sense. Just because the data transfer or data accumulation is kind of cheap, doesn't matter that we need to transfer all the data from one data center to another and train our models on every available data set and so on. And of course, yes, the quantum will be here. First, the quantum security measures, quantum key distribution will be the first into production, which is connected with quantum mechanics, and we will secure our infrastructure on the physical layer. Of course, some other mechanisms like post-quantum cryptography is preparing us for the introduction of quantum computers, and hopefully in the next 10 years we will see the working quantum computer, which has more or less noisy qubits and can perform well already. So yes, but in the meantime, I think we should focus on the energy efficiency and what we can achieve with the means we have at hand.
Yeah, and the chipset point's an excellent one. You know, Qualcomm, what they're doing with their MPUs and what they're doing with Dragonwing, which is their IoT platform, and they're focused on bringing low power AI functionality and security to the chipsets. Adam, do you see anything that's on the horizon that can sort of address the balance that we've been discussing?
Yeah, I mean, I wanted to say quantum, but everyone else has said it, so...
It's okay if you want to say quantum.
I'll be brave, and I will make a bold prediction about AI, which is the best way to look stupid, because it's changing so quickly. But
or look really smart.
I think it'll be post-transformer architectures. So we've been basing all of our... AI has become synonymous with transformers since 2017. I think we're due an updating in architectures, and I suspect that that's related to context distances. So transformers have very large context windows, but we're starting to see that that context is actually too long. Some of the stuff in the context isn't used by the architecture. So thinking more around the distance to the context rather than just whether we can retain the context.
Yep.
Things around short-term memory, I suspect, are on the cards in the relatively near future.
Okay, and Artis, why don't you...
Yeah, so I mean, maybe I continue on your thought, Adam. So like, what we don't have in any of the models right now is continuous learning, right? So basically, if you want to truly incorporate new information, you need to do like either expensive foundation model or a cheaper kind of fine-tune, or just slam it into context, right? But like the way humans learn, we constantly we have this kind of wake-sleep cycle, right? During the day, we accumulate information, we integrate it during the night. I mean, there's papers on that from 80s and 90s, actually. But like, so the ideas have been sort of bubbling under in the ML community on how to do this actual continuous learning. And it's an active topic, but we don't see it in production, right? It's at the demo level. And you know, as the saying goes, like, you know, demos are cheap and production is expensive. So
Right.
it's, and I guess from energy perspective, I guess storage is like one of the things that hopefully humanity addresses collectively in a better way, because we already know how to produce ample, albeit spiky, wind, solar kind of sourced energy, but how to, you know, distribute those spikes across consumption. That's a big. We have systems emerging like BESS systems. There's research into hydrogen fuel cells, and my big hope is that this field matures into where we can, you know, utilize the sun where it's available, and maybe even transport that energy across larger distances than the current kind of electrical grid technology. It attenuates over distance, so there's a, you know, limited radius from where you can transfer energy. But if we have a global energy market and solve it in a way that we can, you know, with fuel cells, we can transport it across longer distances, and then with BESS systems, at least we can balance it over, you know, times of day. We can even, you know, you produce, sun is shining. Well, in this part of the world, it's only shining properly between May and September, but you know, the wind might be blowing or not blowing. So you might want to have 24, 36 hours of battery capacity, ideally, in your data center, so that you can, you know, run it uninterrupted on sustainable basis. And then in terms of security and, well, sustainability, both of these there shouldn't be afterthoughts, right? You should incorporate it from a get-go into the foundations when you're deploying a data center or you're building a cloud on top of that data center. And same, so starts with location selection, with the engineering decisions at every step of the way.
Well, gentlemen, thank you for a very insightful conversation. With that, Artis, I'm going to hand it back to you.
Yes, a round of applause to our panel and our excellent moderator, Will. Thank you very much for delivering once again.